Overview of Book 5. In Book 5 we show QFTs in the gauge field representation, which clearly relates the choice of field theory to a choice of Lie algebra, which, in turn, can be related to a choice of group theory, such as U1 and SU3. From this we can see that non-classical algebraic constructs are ubiquitous in QM and QFT, so a review of group theory and Lie algebras is given in the appendix, as well as a review of Grassmann algebras and other special algebras needed in QM and QFT. Similarly, as regards choice of approach, we find that the Schrödinger and Heisenberg formulations often provide the only tractable way to get a solution for bound systems. In critical theoretical considerations, however, the path integral approach is best, as will be shown. In seeking a deeper theory, the more unified path integral (PI) approach provides important hints as to a deeper theory, see Book 7. In Book 5 we get the highest precision result for the value of alpha, in its role as perturbation parameter. If a calculation of the electron magnetic moment parameter G2 is performed, with all of the Feynman diagrams appropriate to expansions up to 5th order, we get a determination of alpha up to 14 digits, where 1/alpha equals 137.05999. This gives us one of the most precise measurements of alpha known. When a similar analysis is done for the muon G2, given the much larger muon mass, particle production pairs of other particles have a measurable effect, and we are able to probe the lower masses of the standard model that are present. In doing this, in preliminary experiments, there is a discrepancy indicating more particles, e.g. the standard model will need to be extended, possibly with a type of sterile neutrino. These missing particles could be the missing dark matter. The prediction of such in emanator theory, and why there should be an imbalance between the left and right neutrinos, hint, maximum information transmission, is described in Book 7.
Part of the description of quantum field theory entails use of analyticity and other complex structures to encapsulate more of the physics in a complex extension to the space, or dimension. This often leads to formulations in terms of complex integration, with the choice of complex contour specified, such as with the Feynman propagator. One of the main renormalization methods, for example, is to use dimensional regularization, which entails analytically continuing expressions with dimensionality to dimensionality as a complex parameter. There is also the aforementioned shift to complex and to rotate expressions with real time to expressions with pure complex time. In doing this, the statistical mechanical partition function for the system is obtained, with well-defined summation. Thus, a connection between tonality and complex structure, in the time dimension at least, is indicated. The second part of Book 5 describes QFT on curved spacetime, CST, where we arrive at an early analysis of black hole thermodynamics. Here we find that spacetime curvature gives rise to thermality and particle production effects. Black hole thermality was revealed in Hawking radiation, due to the causal boundary at the horizon. Such thermality is even seen in flat spacetime, Book 5, if causal boundaries are induced, such as in the case of an accelerated observer.
QFT on CST has one further gift, critical to the statistical mechanics formalism to follow in Book 6, and that's the spin statistics relation. This relation is usually assumed, along with other critical notions such as entropy and the relation between entropy and density of states. These are all shown, with the presentation path chosen in this physics series, to be fundamental or derivative to the formalism already established in Books 1 to 5, to prepare for Book 6. The choice of time is related to choice of vacuum, which is related to choice of field geometry or observer motion, such as constant acceleration or expansion. If you have flat spacetime QFT with a boundary, then you have thermodynamic effects, e.g. the Rindler observer. In this setting, we can compare the Hawking derivation of Hawking radiation using the Euclideanization trick versus the Bogoliubov transformations of the field to the Rindler geometry from the Minkowski geometry, if chosen as the asymptotic vacuum reference. With QFT on CST, we also arrive at spin statistics as mentioned, and get the final extension of the theory by way of Grassmann algebras, to arrive at thermodynamically consistent Bose and Fermi statistical descriptions on quantum matter.
Overview of Book 6. Thermodynamics is the oldest of the physics disciplines, fire, with unapologetic use of phenomenological arguments and mysterious thermodynamic potentials, entropy. Obviously, thermodynamics is still prevalent today, including in its more quantified form via statistical mechanics. How is this not a failure of the mechanistic description of the universe indicated by Cm and even Qm? Concepts that appeared in Qm, such as probability, are now occurring again. Other new concepts appear as well, including approximate statistical laws, equations of state, heat as a form of energy, entropy as a variable of state, existence of equilibria, ensembles/distributions, and existence of the partition function. Many of these concepts appear in the path integral descriptions with the analyticity methods/extensions mentioned previously, so there are hints of a deeper theory that arrives at much of thermodynamics/statistical mechanics foundation from the existing quantum theory. Book 6 has been placed after the other chapters to await identification of entropy as fundamental in that it can be identified as an intrinsic system function even before getting to thermodynamics. We also already have experience with many particle systems, via QFT, especially in CST where particle creation is almost unavoidable, without directly tackling that scenario, due to QFT effectively already being many-particle, with analytic determination of many-particle system functions, such as entropy. With entropy presented at the outset as an important system variable, the derivation of thermodynamic potentials is then a straightforward process, as will be shown. The standard SM connections to thermodynamics can then be given. Thus, in covering thermodynamics and statistical mechanics, we start with the foundations of the theory mostly established, such as entropy, also with equipartition equivalent to sum on paths with no weightings, etc., with no assumptions. Everything follows directly from the theoretical discoveries outlined in the preceding books in the series. We don't see new connections to alpha, but we do see new structures/effects, especially manifold constructs, as with GR, where we also saw no rho for alpha.
The close ties between QM complexified giving rise to a particle ensemble partition function, and QFT complexified and field ensemble partition function, is now simply a derivative aspect of the fundamental complexation posited. This complexation will be posed in Book 7 with emanation in a complexified perturbation space. From atomic physics, described in Book 4, we also obtain the standard rules on electron shell completion, that is encoded in the periodic table. Similarly, we can also understand the origins of the intermolecular quantum chemistry rules. When taken to the statistical mechanics (SM) extreme, we have thermodynamic equilibrium emergent from the law of large numbers (LLN) and reverse martingale convergence. With completion of application to chemical processes, we have clear phase transition effects, as well as equilibrium and near-equilibrium effects. The familiar chemistry results with phases of matter. From chemical equilibrium and near-equilibrium, with 10 to the 23rd power elements that interact weakly or not at all, we have two generalizations. The first is to consider chemical near-equilibrium and directly obtain an emergent process at this level. This is the branch that gives us biology/life at its most primitive level. The second is to consider equilibrium and near-equilibrium in general when the elements interact strongly, with 10 to the 10th power elements, say. This is the branch that describes biology/life at its most advanced social level in economics. In classic shot noise, the granularity of low current flow, due to discreteness off electron charge, leads to a noise effect. Thus, as we consider situations with fewer elements, there are more complications, not less, due to granularity noise effects, and we enter the realm of machine learning with sparse data. Noise effects can be significant in complex systems, especially in biology where it is part of what is selected, such as in hearing, for background noise cancellation.
The second part of Book 6 explores the role of thermodynamics in efforts to extend to TQFT and TQG. This is done by exploring black hole settings. The recognition of a role for complex structure on system variables becomes apparent in this process, on top of the generalization to non-trivial algebras as already revealed. In Book 6, Part 2, we examined the Hamiltonian thermodynamics of some black hole geometries with stabilizing boundary conditions. In this foray into directly exploring a thermal quantum gravity, TQG, solution, we assume a path integral form for the GR problem and shift directly to a partition function, by Wick rotation mentioned above. We see that TQG is possible, where positive heat capacity shows stability. Another encouraging result as to an eventual unifying theory comes from string theory via its explanation of BH thermodynamics and BH horizon effects with the BH fuzz solution, via use of the holographic hypothesis and the related AD-SCFT relation. In Book 6, Part 2, we also examine the propagator-to-partition function transformation upon complexation, which leads to a thermodynamic theory for some equilibrium formulation, with certain parameter settings required for stability, positive heat capacity. This is doable in a variety of settings, suggesting how such thermodynamically consistent boundary conditions may be what constrains the classical motion and BH singularity formulation by the effect of this stabilization manifesting for certain internal geometries. Successful TQG, thermal quantum gravity, formulations, such as for Arnott-S and Lovelock spacetimes shown in Book 6, via reformulation using analyticity, and not via non-analytic approaches, suggests a possible fundamental role of analyticity once again, and also suggests that TQG may exist or be well formulatable, while QG generally might not exist. These results, together with core concepts from Books 1 to 6 that tie to emanator theory, are brought together in a new theoretical synthesis in Book 7.
Overview of Book 7. In Books 4, 5, and 6 of the series, we explored examples of QM with imaginary time, QFT in CST, thermal QFT, mini-superspace QG, and thermal QG. In this effort, we find the path integral and PI propagator to provide the most general representation. In seeking a deeper theory in Book 7, we build on the summon paths with propagator formulation to arrive at a summon emanations with emanator formulation. Propagation in a complex Hilbert space in a standard QM or QFT formulation requires the propagator function to be a complex number, not real or quaternionic, etc. This prohibits what would otherwise be an obvious generalization to hypercomplex algebras. In order to achieve this generalization, we have to introduce a new layer to the theory, one with universal emanation involving hypercomplex algebras, Trigon-Tedouanians, that is hypothesized to project to the familiar complex Hilbert space propagation with associated fixed elements, e.g., the emanator formalism projects out the observed constants and group structure of the standard model. The projection is an induced mathematical construct, like having SU3 on products of octonions, but here it would be the standard model U1 XSU2 XSU3 on products of emanator Trigon-Tedouanians. Thus, in Book 7 a unified variational formulation is posed, one that arrives at alpha as a natural structural element, among other things, uniquely specified by the condition of maximal information emanation.
In Book 7 we also make note of the implications of a fundamental mathematical operation on a space that is repeated or added. The non-GR forces are given by the form of the operation, the sequence forming an associative algebra. The GR forces are given indirectly by the form of the space. This leaves the aspect repeated or added to be considered with care. If a purely repeated operation, or mapping, occurs, we can return to the dynamical mapping discussion of Book 1, where chaos can occur and is ubiquitous. There, the primal phase transition, the transition to chaos, is evident. If an operation with addition is involved in the statistical sense of multiple elements, along with repeated overall steps, we arrive at the general framework of statistical mechanics with effects from the law of large numbers, LLN, and reverse martingale convergence, among other things, Book 6. Most notable, however, is the prevalence of a new effect, that of phase transitions and the emergence of new structure, order from disorder, including the remarkable structures of chemistry and biology. Why the recurring Kabbalistic formula? Was a question even in the time of Sommerfeld. Now, the numerological parallel is more exact than realized at that time, so is too much a coincidence to be by chance. The non-coincidence appears to be due to the maximal nature of information transmission in a variety of circumstances, in physics, biology, and even human communication with sufficient optimization, as well as with the fractal-like repetition of key parameter sets that occurs in these different settings. 10, 22, 78, 137 is approximately equal to 1/alpha. We see that 10 expresses the dimensionality of propagation, or nodes of connectivity, while 22 corresponds to the number of fixed parameters in the propagation. In Book 7 we explore propagation in a 10-dimensional subspace of the 32-dimensional Trigon-Tedouanian space, leaving 22 dimensions at fixed values that appear as parameters in the theory. We will see the number 78 relates to generators of the motion, and that there are 4 chiralities of motion, doubly chiral. We will also see that 137 is simply the number of independent trioctonionic product terms in the general chiral trigentidonian emanation.
Synopsis. Frodo lives. Tolkien wrote of eucatastrophes. Perhaps he anticipated the constructive role of emergent phenomena in maximum information transmission.